Okay, welcome back to the next lesson in this unit. We're going to start in section 12.2. The target for today is writing a rule for an arithmetic sequence. Okay, arithmetic rules, they have a common difference. We call it D. Okay, so the first thing we're going to do is decide whether a sequence is arithmetic or not. To find out if a sequence is arithmetic or not, we simply look and see, is there something that we add over and over again to get the next value? So we look here, we can see that we're adding 3 from value to value. So we say, yes, this is arithmetic, and D is 3. If we look at this set of numbers right here, we can see that we subtract 6 every time. So even if we're subtracting, it's adding a negative, so we say yes, and D equals -6. Down here, well, with the C numbers, there doesn't seem to be a discernible pattern that's at least a common difference. Looks like we plus 6, then we minus 4, then we plus 6, then we minus 4, then we plus 6. So that is a pattern of some sort, but it's not arithmetic because we're not adding the same thing over and over again. So no. Okay, so that means there's no difference. Okay, so rules for an arithmetic sequence. This is the model, if you will. A sub n equals a sub 1 plus d times n minus 1. A sub 1 is the first term. D is the common difference. We just looked at that. N is the input. Input for the x term, if you will. And a sub n is the output for the y term. You're thinking of this y equation. So write a rule for the nth term of an arithmetic sequence, then find the 20th term. Okay, let's look at this equation. Okay, if we look, we can prove this is arithmetic because we add by 4 every time. So if we identify some key characteristics of this equation, they would be a sub 1, which is 6, that's our first term, and D, our common difference, is positive 4. So we plug this in, we get 6 plus 4 times n minus 1. Now, that is an equation, but on your test, I'm going to expect you to write this in slope-intercept form, which means y equals mx plus b. So when I want it done, I want it to look like this. Y equals mx plus b. So we're going to distribute that 4, and then we're going to combine like terms. 6 and -4 is 2. So this equation ends up being a sub n equals 4n plus 2. Okay? We can see, we'll start down here just to prove it's arithmetic. These are like denominators. So we can see that we go down by 5 each time. So our common difference is -5/9. And our a sub 1 is 11/9. So we can plug this in. 11 over 9 plus -5/9 times n minus 1. And I'll leave that for you to put in slope-intercept. Okay, write a rule for the arithmetic sequence. They give the first 6 terms. Oh, let's go back. I forgot on this last one. They wanted the 20th term. How do I do that? Let's just look at a sub n here equals 4n. The 20th term is really a sub 20, or plug 20 in for n. 4 times 20 plus 2, well, that is just what? 80 plus 2, or 82. So a sub 20, or the 20th term, is 82. Just plug it in. Okay, on this one, now I'm going to give you the difference in a different term. How can we find the rule this way? Well, we look at the equation a sub n equals a sub 1 plus d times n minus 1. Okay, so our difference is -7. Okay, we know our 11th term, so n, the 11th term, is negative 57. So this is really our x, and this is our y. We can plug those in, we can simplify, and we can solve for a sub 1. So that's negative 7 times 10 equals negative 57. Of course, that a sub 1 there. That's negative 57 equals a sub 1 minus 70. Add 70 to both sides. We get, we get 13 equals a sub 1. Now that's crucial because now we have a sub 1 and we have a common difference. So we can go back and we can put 13 plus a common difference I just looked at. It was negative 7 times n minus 1. Now we can distribute, combine like terms. And we get 13 plus 7 is 20. We get a sub n equals negative 7n plus 20. There's the rule. What else do they want to know? It said graph the first 6 terms. I'm probably not going to necessarily make you do that in this class, but if you want to graph the first 6 terms, we need to make an x, y table. So 1, 2, 3, 4, 5, 6. We find the first 6 values. The fastest way to do this really is just to go to your graphing calculator, put negative 7 and which is x, plus 20 in, go to the table, and we want the first 6 terms, so we just make sure 1 through 6 show up on our table. And if you have a blue calculator on 9 on the screen, you can just slide them out. There's our first 6 outputs: 13, 6, negative 1, negative 8, negative 15, and negative 22. You can it wouldn't be that hard to pull a room right here as well. If we're going to graph them then, we just say, okay, up to 13 and as low as 22. 7, 8, 9, 10, 11, 12, 13, 7, 8, 9, 10. Should have gone by something other than 1 is here. That's okay. Okay, so 1, 2, 3, 4, 5, 6. Over 1 up 13. Over 2 up 6. Over 3 down 1. Over 4 down 8. And over 5 down 15. Over 6 down 20, 22. And then we graph the first 6 terms. Okay, I think we've accomplished our goal for today. We have written a rule for the arithmetic sequence. Have your notes ready to go tomorrow, and we'll have some more problems for practicing class. Have a good day.